Hello and welcome. I'm Pravir, and today I'm going to focus on leveraging imagination to surface quantum technologies. Now, to start this session, I want to draw on a quote by Albert Einstein. I believe in intuition and inspiration. Imagination is more important than knowledge, for knowledge is limited, whereas imagination embraces the entire world, stimulating progress, giving birth to evolution. It is, strictly speaking, a real factor in scientific research. And I bring this up because clearly our session is focused on imagination, and I'm going to apply imagination at the quantum levels. And at the very least, this should suggest different approaches, the creation of different hypotheses to conduct further research, which then, as I will suggest in this session, lead to different extrapolations of quantum technologies, possibly. The objectives are to use imagination to see things differently, and here strictly at the quantum levels. I want to introduce a quaternary interpretation of quantum dynamics that has emerged through the exercise of imagination, and finally surface potential technologies that may result from such an approach. So the approach of a quaternary interpretation of quantum dynamics. So this session is going to be broken up into these parts. We'll start with the power of imagination. We'll use imagination to look at a fourfold structure of matter and life and connections between the layers of matter and life. We'll then have an imaginative view of light and quanta, and this will lead to an introduction to the quaternary interpretation of quantum dynamics, which is a system that I've put in place over years. So it's research that has gone back many years. And finally, quantum technology extrapolations based on the interpretation. So starting off with the power of imagination. Now, we've had many instances of dream being the source of imagination or inspiration. And here are, I'm just using examples from the scientific realm. So we have first on the top left corner, the structure of the atom that supposedly was influenced by a series of dreams that Niels Bohr has or had. And in the appendix to this presentation, I have the sources for the claims that show up here. So these can be independently viewed as well. Second, and surprisingly, René Descartes, the father of scientific thinking, apparently arrived at his approach to scientific thinking through a series of dreams. We have Otto Loewi, Nobel Prize winner, for coming up with the idea of chemical process for neurotransmission, which was earlier thought to be electrical. Kekulé for the structure of benzene, and while he didn't get a Nobel Prize, 3 of his students got Nobel Prizes in chemistry. And he had a dream about a snake biting its own tail, and that gave him insight into the structure of benzene. And finally, the Indian mathematician Ramanujan, who used to have dreams in which many formulas would emerge, and he went on to be a research fellow at Cambridge University, and his work has been instrumental in thinking about mathematics in general. So now, beginning to apply imagination. So, of course, we're in good company when we look at those scientists and mathematicians. And the question is, how can we leverage imagination to begin to look at the quantum levels? So I'm going to pose some what if scenarios here. So what if superposition and entanglement, which are pillars of today's conception of quantum computation, in fact, work differently than imagined? And I bring this up simply from the common interpretation of quantum mechanics, which is the Copenhagen interpretation, which suggests that there's unknowable infinite possible states that collapse into one single state when measured. So what that implies is that since the unknown infinite is collapsing into something that's finite and measurable, when measured, then by definition, we would not know what's in the black box of the quantum realm. So our understanding or our modeling of the phenomena of superposition entanglement may in fact be quite different than we imagine it. What if entanglement never has to be created? Of course, a pillar of our modern approach to quantum computation is that we're creating entanglement between quantum objects, and that facilitates the speed up in quantum computation. But if we look around us, then we know that matter may already be entangled just naturally. So, for example, there's no two snowflakes alike, there's no two thumbprints alike, and that could suggest that all thumbprints or all snowflakes are already entangled. And therefore, we may have to just use entanglement differently, entanglement that already exists, rather than trying to create it. What if superposition is suggesting that there is indeed some order to nature? Because our common conception is that from the modern scientific view, and even from the design of quantum computation that relies heavily on probability and then statistics, is that nature is random. But in fact, we may conceive of superposition as being a phenomena by which certain functionality is superposed on physical form, which gives us then a different view into the non-probability of aspects of nature. And I bring these up in terms of what if and to jumpstart this session, because our interpretations of superposition, of entanglement, and of the probabilistic nature of nature and the quantum realm is instrumental to our conceptions of quantum computation. But if these in fact work differently, then there is an entirely different approach that's suggested to quantum computation. Now, going further, and I had a separate session, an hour session in December, where I went over in some detail the double slit experiment and suggested how it can yield, by looking at it or imagining some of what's happening differently, it can yield different approaches to quantum computation. And just as a reminder, the double slit experiment, which I think, if I remember correctly, it happened toward the end of the 19th century, and it's been instrumental to launching our investigation into quantum dynamics. And this is simply because when we consider a source of light that's referred to here as a WL in this double slit illustration over here on the top right hand side, and if this light source flows freely from the source and then it goes through two slits, so the double slit, then it would result in an interference pattern on a screen that's placed behind the double slit. And that's intuitive, that's kind of is aligned with our conception of how things work. However, what's surprising, and the reason why the double slit experiment has been so central, is because even if there's single photons that are emitted from the source one at a time and sent through one or the other of these slits. When we think about that, we would imagine that there would be a pattern on the back end, which would just be two strands directly behind these slits. But in fact, what's happening is that it also results in a full interference pattern. And that's considered to be, by some, the experiment that quote unquote broke reality. And there is a common interpretation that goes with, is consistent with ideas of superposition and entanglement that I had shared on the previous slide. But basically, I would call that a bottom-up approach. And summarizing the key idea there is that if you've got photons that are emitted, somehow they share past and future with all other photons. So they take on infinite values. And then when they arrive at the screen behind, they know which uh, spot to occupy in order to create the perfect interference pattern. So there's a shared history, there's a shared future. This implies that all of the photons are entangled. And so that's kind of the sense, if you look at it from the bottom up, from the point of view of an individual photon. And that leads to a certain trajectory of thinking. However, if we then use imagination to look at the same experiment differently and interpret it differently, so that you've got this source of light, which I'm referring to as WL, and then there's specific properties that this light has. And if photons are aligned or correlated with these properties, then they're carriers of those properties right through the experiment. And we could say that here, metaphorically, the placement of these photons on the back screen is correlated to these properties. And so in some sense, then there's no need for photons to be entangled in the way we're imagining or to have infinite values, because they're already aligned with a specific property that, in a sense, determines where they're going to show up on this screen. So if we take that approach, it yields, as I had gone through in some detail, I'm not going to do it here, but in the previous session, it yields different trajectories of thinking and development. And the point being that now, as opposed to the common trajectory or the modern day trajectory of quantum computation and the development of quantum computing, there are now alternative trajectories that are suggested if we use imagination to interpret what might be happening in the double slit experiment. So this leads us into the idea of a wholeness of light. So there's something that about light that is very, very tangibly determines what is happening in this entire experiment. So it's embedded into the space-time description of this experiment, in a way of looking at it. So coming to this idea of whole, let's look at the fourfold structure of matter and life and employ imagination here. So we can imagine that nature is a single system. So why? Because we can say that all quantum particles are sourced from quantum levels. All atoms are sourced from quantum particles. All molecules are sourced from atoms. All molecular plans, that's the basis of any living cell, are sourced from molecules. And so it's evident there's a tight integration between one layer of nature and the next. So the question is, why don't we study it as a system when trying even to get insight into a single layer? My point being that if we want to understand the quantum level, then why don't we look at the system as a whole? If, in fact, everything that emerges in matter and life is already intimately tied and must give us some insight into what's happening at the quantum level. So this would give us perhaps additional insight into quantum dynamics itself. And this is where I'm going to go now. So using reverse extrapolation to read the quantum level, and again, this is an exercise in imagination. So here we have a depiction of the cell, and I want to draw attention to the fact that any living cell has 4 molecular plans in it, and these molecular plans are called proteins, polysaccharides, nucleic acids, and lipids. Now, what I'm doing here in this exercise of reverse extrapolation, and I'm going to just focus on this level to begin with. I want to get these different molecular plans so to some functional denominator, something that's common that gives us the essence of what a protein is doing, what a polysaccharide is doing, what a nucleic acid is doing, what a lipid is doing. And so I want to suggest that if we think about nucleic acids, for example, we know that they're instrumental in the creation of DNA or the creation of the libraries of the cells, so it has something to do with knowledge. So there's a denomination, or we can normalize the function of nucleic acids and say it has something to do with what we're calling knowledge. When we think about polysaccharides, then we know that they're sugars and they're instrumental in providing energy to the cell. And so we can normalize that to a function of energy or power. When we think about lipids, we know that lipids create natural compartments in cells, and this allows work, differentiation, and specialization. So there's a natural harmony that comes about. And so in some sense, lipids can be normalized to a function of harmony. And when we think about proteins, we know, for example, that in a human cell, there's over 30,000 different proteins, each conducting something very precise. So the proteins have a presence, they create a service, they provide service to the cell. So if there's some kind of function that we want to normalize this to, we can call that, just roughly speaking, presence. Now, I want to look at going a further level of granularity. So reverse extrapolating to the periodic table. And we know that the periodic table is broken into 4 categories: D shell atoms, S shell atoms, P shell atoms, and F shell atoms. Now, I want to propose that if we begin to normalize what these different categories stand for, then we can see that in fact they can be normalized to these functions of presence, power, knowledge, and harmony. And just to give a sense of that, so S-shell atoms, for example, has atoms like hydrogen and helium. We know that they're instrumental in nuclear fusion, in powering all the stars. And so it has something to do, if we're to normalize that, it may have something to do with this function we're calling power. Similarly, if we think about P-shell atoms, then we know that it has, for example, atoms like silicon or carbon that have been leveraged extensively in the creation of thinking machines and life. And in addition, there's other kinds of archetypes in the P shell, such as metals, metalloids, non-metals, and so on. So there's some kind of imprint of some of what's going on in the rest of the periodic table here in the P shell. So I could say that then the P shell atom becomes or can be normalized to this function of knowledge. If we think about the F shell atoms are, I would say, experiments in collectivity. They have the largest atomic numbers, so there's some kind of normalization to this function of harmony. And then if we think about the D shell atom, then we know these are instrumental in, for example, industrial elements, whether of iron, steel, copper, aluminum, cobalt, and so on. And they create a lot of the infrastructure and provide the presence, if you will, all around us. So in that sense, these are being normalized to a function of presence, power, knowledge, harmony. And if we go one level deeper, so to the quantum particle level itself, We know that the quantum particle level is again broken into four different categories: Higgs boson, leptons, quarks, and boson. And if we think about this, we know, for example, that the Higgs boson is instrumental in providing any quantum particle with mass through the supposed interaction with the Higgs field, and so it has something to do with presence. When we think about leptons, then using electron as a surrogate, whenever there's a release or capture of electrons, that's accompanied by the release of power. So this is normalizing to this function of power. When we think about quarks, quarks entirely create protons. Protons, we know the number of protons will determine the atomic number of an element. And the atomic number, for example, if you've got 47, will precisely tell us how that atom is going to behave in the universe and what its function is. And so, for example, we know that there is an atomic number of 47. It's going to have properties of malleability, ductility, superconductivity, resistance to oxidation, and so on. So the point being that this is determining the knowledge that by which it's going to interact with everything around it. And then bosons, we know, are instrumental in connecting together other quantum particles, and so they can get normalized into this function of harmony. The point being is that when we look at this using imagination, then we're finding that there's a common pattern that runs across these three different distinct layers, and we can hypothesize that this pattern appears in root form at the quantum levels. So it's suggesting that even though when we try and measure things at the quantum levels, it may seem impossible because it's going to collapse into something measurable. But now if we assume through what's arisen from the quantum levels, that what some of the dynamics are, and here I'll refer to these as the fourfold dynamics of presence, power, knowledge, harmony, and they exist in some root form at the quantum level, then that creates a hypothesis for how to create instruments and the kind of technologies that might extrapolate from there. So now, we looked at basically the quantum level from the top down. I want to now approach it from the bottom up. And so I'm going to run a thought experiment on light at a different speed, light traveling infinitely fast. So imagine that you've got a source of light that's traveling infinitely fast, and there's a volume. It could as large as we want it to be, the size of the galaxy or the universe or just a room. And because it's traveling infinitely fast, it's going to be present everywhere. So there's this property in light, or something that is being suggested, that is about presence. If anything not of the nature of light were to arise in that volume, it would be overpowered by light. And so there's a property of power that is suggested. Since light is instantaneously present everywhere, then anything that arises or disappears is doing so in its fabric. And so light, quote unquote, has a knowledge of everything that's happening in its space. And so that's another property. And then finally, since everything's happening in the nature of light, there's an implicit harmony. And so there's these four properties that are being suggested in this thought experiment. And even if, continuing with the imagination, if light were to project itself at a slower speed, so the known speed of 186,000 miles per second in our physical universe, then we may surmise that there'll be something of these four properties that would show up and be instrumental even in that layer where light is traveling at 186,000 miles per second. And here, just a reminder of what we went through earlier. We in fact said that in the physical universe, from the quantum realms, there's layers of matter and life arising that also have these functions of presence, power, knowledge, harmony. Now, we can think of the quantum as something that collects and materializes information in light. So from this imaginative point of view, if we have this realm where light's traveling infinitely fast, and assuming it has infinite information in it, then when it projects itself at a slower speed at 186,000 miles per second, then we may think of quanta as being a bridge mechanism that basically is taking information from the infinite field around it and materializing it in some form in the physical universe. And so this also gives rise to the what I'd call a fourfold quantum object code. And what do I mean by this? So basically, we're saying we have light traveling infinitely fast. It projects itself at a slower speed, and there's some action of quanta that is materializing possibilities in the infinite field, in the finite field, and we can think of these properties as having, or the information as having at least four facets that we're calling presence, power, knowledge, harmony. And imagine that these are large concepts. So, for example, like power could be defined as a set of all elements related to power. That's the pink circle over here. Or presence could be defined as a set of all elements related to presence. And so you could have practically infinite sets for these four properties that help us to mathematize the information that may exist there. And then further, we could have another act of quantization where we have subtle seeds that are created, and these subtle seeds can be thought of as unique combinations of the elements that exist in these other infinite sets. And then these seeds are what in this imagination is being materialized by the bridge dynamics of the quanta and then showing up in material form in the physical universe. So if we consider these seeds that now are materializing something from the infinite field and the finite field, then this could be a definition, or we can think of this as space. So space being granular in this point of view and consisting of all the possibility that shows up materially in the physical universe. Time could be the working out of what's contained in these subtle seeds into material form. And so, regardless of any kind of obstacle, um, ultimately, whatever is contained will materialize itself through the action of time. Energy can be thought of that process by which that which is subtle becomes more and more concrete. And then gravity can be thought of as an arrangement between different kind of possibilities in specific ways. And if we can normalize these space-time energy gravity to also what they stand for in their essence, we can say that since space has an archetype of all the possibilities that are going to arise physically, that it has something to do with knowledge or can be normalized to knowledge. Similarly, since whatever exists in seed form is going to materialize regardless of the obstacles, there's time can be normalized to this idea of power. Energy, since it's taking something subtle and making it material, it can be normalized to this idea of presence. And gravity, which is suggesting a relationship between different seeds, can be normalized to the idea of harmony. So the point, or using imagination, we can say that any quantum object that shows up in this realm here where light's traveling at 186,000 miles per second has to, in a sense, have this fourfold quantum object code that will define how it is going to behave, what its properties for evolution are, how it's going to transform itself, who it'll or what it'll interact with, what are the quantum objects. And so in some sense, there's a fourfold quantum object code that's associated with every quantum object that has something to do with what we can call space-time energy gravity coordinates. So with that, I want to introduce quaternary interpretation of quantum dynamics. And summarizing, we had an infinite, light traveling infinitely fast, and this gives rise to the idea of infinite elements of presence, power, knowledge, harmony, depicted here by four sets. And then we have the elements from the sets combining in unique permutations, combinations to create infinite number of unique seeds. These are subtle seeds that then populate space-time energy gravity. And this then becomes the quantum object code, or rather the space-time energy gravity coordinates will accompany any quantum object that shows up. And then we had when we looked at the idea of reverse extrapolation, how quantum particles, atoms, and molecular plans can be categorized into these properties of presence, power, knowledge, harmony, or be normalized to them. And I'm not going to go into it, but similarly, I've written extensively about this. And also in the appendix to this presentation, I have all the IEEE articles, the books, and so on that inform everything that you're going to see in this presentation. And so the idea is that you've got a fourfold expression that's instrumental to this quaternary interpretation of quantum dynamics. And further, what we can also say is that if this is layer 0, and you've got layers 1, 2, 3, 4, 5 that show up or determine the material, known material universe, then you've got imaginary layers that are behind this 0 layer. And so several kinds of imaginary layers that go into mathematically into these realms of light. And so the components of the quaternary interpretation are, one, quanta being a bridge mechanism between infinite possibility and materially what shows up, the quaternary expression that we just went through, the quantum object code that would accompany every single quantum object. And then because we're talking about many different layers here, there's an interaction of these layers. So there's a persistent computation that would in fact result in an enhancement of what shows up materially and even new forms being suggested in the future. So now the question is, when you've got this quaternary interpretation, then what are some of the technological extrapolations? So if we look at the atom, then I can make the claim that the atom is the most successful instance of a quantum computer. But if the quaternary interpretation is true, then what it suggests is that there's a different way in which atoms can be leveraged. And just to point out why I say the atom is the most successful quantum computer to date, we know that atoms are completely comprised of quantum particles. You've got the nuclei made from quarks bonded together through the action of bosons, electrons, another type of quantum particle that exist in stable orbits around the nucleus. We know that electrons exist in multiple superposed states. So already we see the phenomena of superposition over here. We can hypothesize that all atoms that have the same atomic number exhibit the same properties, and therefore all the atoms must be entangled in some way. So we see the phenomena of entanglement already being there. And then also we know that the lifetime of these quantum states endures. So they don't just exist for a few nanoseconds. So we've got a very successful quantum computer here. And we can think of it as a quantum computer because we know that its state continually changes. So for example, if we send a stream of photons to the electron, it's going to change its states and it's going to output either photons or electrons. And then atoms, we know, are robust in a number of different environments. We know further that atoms are scalable because they exist still in robust form, even when combined with other atoms and so on. So the question is, since atoms are instances of quantum computers fully embodying quaternary dynamics, what technological other implications come to mind? So first of all is the idea that we have naturally occurring quantum computers, and I'm going to elaborate on that. That creates some kind of genetic type code. So the first question is, since the atom is a quantum computer, what exactly is it computing? And it's computing code, and I've given the example of atomic number 47 that will precisely determine its set of functions and how it behaves in the universe. This can be thought of as code that we haven't learned to read yet, but I'm hypothesizing based on imagination that it has four dimensions, the space-time, energy, gravity dimensions embedded in that code as suggested by the fourfold quantum object code that is part of the quaternary interpretation. This code can be thought of as pre-genetic code that exists for the same purpose as genetic code in cells. And then the question is, what are other instances of naturally occurring quantum computers? So since atoms are at the base of molecules, we can say that all molecules are more sophisticated quantum computers as compared with atoms. We can say that molecular plans are even more sophisticated because they comprise of different combinations of molecules. And then we can also say that cells are an instance of very successful quantum computers because they comprise of a lot of variations on molecular plans. So what are the cells computing? So they're computing code, they're running by genetic code, and this maintains the integrity, possibilities, boundaries beyond which cells breakdown occurs due to a vast range of inputs and so on. So that's something that, again, the question is knowing that if, as per this exercise in imagination, you've got all these naturally occurring quantum computers and they're all displaying fourfold dynamics, they're all run by it, then what does that imply technologically? What are some of the implications and thoughts that come to mind? So first, I'd like to draw attention to this idea of quantum computation and AI. So if we look at the development that we just went through, for example, like from atoms to molecules, molecular plans to cells, and so on, then it appears that intelligence is continually codified and upheld by these naturally surfacing and progressively more sophisticated quantum computers. So what's the implication of that? It implies that there must be some repository of quantum intelligence natively at the quantum level. So this is, again, through imagination, we're suggesting that there's another property. There's something called, we've already said that there's something called fourfold dynamics, which is a property or a mechanism existing at the quantum level. Now we're also saying that there's something called quantum intelligence, again, using imagination that must exist at the quantum levels because it surfaces as more and more sophisticated form. And so if this intelligence is a native property of the quantum level, then the question is, how would AI compare with this quantum intelligence? Well, AI, as we know, can be thought of as a subset of conceptual mechanisms that derive from human intelligence. But human intelligence is an outcome computed into existence from the layers of the quantum levels. And so, by definition, quantum intelligence, from which all other intelligence arises, must possibly be vastly more intelligent than instances of intelligence that arise from it. So, what that implies is that if you've got any AI or projected singularity that ignores this possibility, it's going to be leapfrogged by it, provided that the right kind of computational devices are created to actually leverage this thing that we can call QI. So given QI, how might we want to design quantum computers differently? So here are some considerations. So first, we have to go through a process of intuitively understanding what exists at the quantum level, and this is what we've done by using imagination in this session. We have to learn to read it, and that would require a different kind of instrumentation altogether. We have to learn to leverage dynamics such as fourfold or other dynamics that we find there. And then we also want to create technology or computers that can integrate this idea of quantum intelligence into its functioning. So in other words, it would have to have some kind of organic capability to to read organically what's happening. And we can refer to such a computer as housing integrated quantum computational intelligence, and it would be a nano-sized, and therefore we can refer to it as the IQCI nanocyborg. And again, I've written some IEEE articles on this and also Forbes articles on these nanocyborgs. I also want to mention briefly that I did file a patent a couple of years ago, and this is based on this idea of using nanocyborgs to tap into the quantum levels and access different dynamics. And so here you see depiction of some of the uh, quote unquote gates and some of the math that would run that kind of quantum computer. So the question is, what are some possibilities of such nanocyborgs? So first of all, there's revolutionary access to generation of materials, which could change the foundation of material sciences. And this derives from our consideration that we may be able to affect atoms and molecules and the genetic type code they generate from the bottom up, if in fact we begin to see this quaternary, what the quaternary interpretation of quantum dynamics is suggesting. Similarly, we would have revolutionary access to the management and maintenance of life. And for a similar reason, because we're affecting molecular plans and cells and the genetic code they generate, also potentially from the bottom up. And we could also potentially be able to facilitate the emergence of other forms of intelligence once we learn to organically interact with it and into what's happening there. There may be ways to bring these out in different forms, but also pushing the possibilities even further. We know that at the quantum levels, from this point of view, IQCI-based nanocyborgs would potentially give access to fourfold patterns that animate layers of matter and life. And we've hypothesized that the root of these fourfold patterns is a quantum level space-time energy gravity pattern. And I would suggest that it can bring about revolution in a couple of areas. So first of all, being at the source of all the fourfold patterns that we see arising in matter and life and the infinite, practically the infinite amount of energy that these, for example, atoms or cells or molecular plants hold in themselves, this suggests that the base fourfold pattern is also giving us insight into the operation of this inexhaustible reservoir of energy. So there's hypothetically an inexhaustible energy source that we can tap into. So beyond terrestrial uses, it can, using imagination, be leveraged for extended space travel. And then since we're looking at the quantum levels and we're suggesting from our model earlier, the model that I had suggested earlier, that there are at least conceptually faster than layers, faster than light speed layers, then perhaps in some use cases, if that's the case, that might be leveraged once we know what we're doing at the quantum level from a quaternary perspective to allow faster than light speeds in some instances. And then further, IQCI nanocyborgs would allow deeper interaction with quantum properties beyond our hypothesized ones of superposition, entanglement, tunneling, and annealing. So I've suggested quantum intelligence and fourfoldness, but there's surely other kinds of dynamics and properties that exist there. IQCI nanocyborgs could also co-create in partnership with the underlying quantum intelligence by generating different kinds of quantum patterns. And finally, it's in learning to perceive, manipulate, and leverage these that perhaps extraordinary quantum intelligence-enabled technological possibilities will surface. So summarizing the key points, so using imagination, we first started off with different interpretation of pillars of modern quantum computation, at least how it's being designed, are superposition, entanglement, and the probabilistic aspect of nature. We looked at double slit dynamics. It just suggests that there's other trajectories using imagination of quantum computation. We considered the idea of nature as a single system and how that would be instrumental in actually studying the quantum levels. We looked at the fourfold structure of matter in life. And of course, we know scientifically that already layers of matter in life are defined having four categories, but we also hypothesized a fourfold structure of light. We then went into the quaternary interpretation of quantum dynamics that has quanta as a bridge mechanism. It has fourfold expression that originates in those imaginary layers of light. We have space-time energy gravity code that surrounds every quantum object. And then we have the idea of persistent computation that leads to refinements and emergence of new form. And then the technological possibilities that are layered on this different point of view, where we leverage atoms, molecules, molecular plans, and cells differently because we know that there are quantum computers that have this fourfold quantum object code and operate differently than in addition to how we've imagined them. We have the bottom-up access to genetic type code. We have this notion of quantum intelligence and leveraging that. And then we've got the possibility of creating a QI type quantum computer. And then the specific QI quantum computer that we're calling nanocyborg, we're suggesting it will have profound effects on material sciences, maintenance and management of life, and leveraging quantum intelligence. And then also we're suggesting it would give access to an inexhaustible energy source, different ways of space traveling, quantum feedback mechanisms, and quantum patterns. So that brings this presentation to an end. And what I want to do is I want to draw attention to the appendix that I mentioned. And there's in the appendix, there's deeper sources for the different scientists and mathematicians. And then in addition, there's links to different layers of the writings. So these are a series of 10 books, a mathematical treatise on light, and that stand behind the quaternary interpretation of quantum dynamics. There's a number of ongoing IEEE quantum articles. These all have been peer reviewed and presented and published in IEEE conferences that go into, again, this light-based view of quantum dynamics. And then there's shorter, more business oriented Forbes articles, and there's a series of 9 that again go into this vision of quantum computation. So with that, I'd like to end, and thank you for attending this session.